In today's lesson, we're going to be talking about a function and its derivative. You'll notice here I have the function y equals sine of x and its derivative in orange, y equals cos of x. So if you take a look here, you'll notice that when this function in green here, my original function, is increasing, our derivative, in this case y equals the cos of x, is above the x-axis. So notice here, take a closer look here. Whenever my function in green is increasing, its derivative is above the x-axis, and whenever my function is decreasing, you'll notice that my derivative is below the x-axis. That's because decreasing functions have negative slopes, and therefore the slope is below the x-axis. Also, make the following observation. Whenever my function in green hits a maximum or minimum value, your derivative crosses the x-axis. You can see that here. Every time that function hits a max, its derivative crosses the x-axis, because at the max or min, we have a horizontal tangent, a horizontal slope, and therefore its derivative is 0. Let's take a look at our next function. Here we have the function y equals x and its derivative, in this case y equals to 1. Notice here that as my function is progressing through here, the slope is not changing, right? Any linear equation, any linear relation has a constant slope. Therefore, its derivative would be a constant number. In this case here, the derivative is y equals to 1. So notice the slope of y equals x, anywhere you go on that graph, has an instantaneous rate of change of 1, and therefore its derivative is going to be a flat line at y equals to 1. Moving on here, we have y equals x squared, and its derivative is 2x. Notice here you'll see that as my function in green here tends towards the origin, you'll see that the slopes which are decreasing, so negative, and my function is below the x-axis. And notice here that the slopes are tending towards 0, so they're getting smaller and smaller and smaller until they hit 0. And then you'll notice here that when the slope is 0, my derivative crosses the x-axis. Right, so you can see that here from the function. Very steep negative slopes, and then tapering off until we have a slope of 0. And then your function crosses the x-axis, its derivative crosses the x-axis, and then we have positive slopes, increasing function, and our derivative is above the x-axis here. All right, let's take a look at that one more time, try to make that connection between these two. You'll see again, the derivative is tending towards 0 because the slopes are becoming less and less steep. Right, you have maybe a slope of, let's say, -10, then -5, then -3 until the slope becomes 0. Then the slopes tend to be positive, increasing function, and your derivative, y equals 2x, is now above the x-axis. All right, now we're going to take a look at y equals x cubed. So that's in green here, and its derivative is 3x squared. Now again, as you see here, your function is an increasing function, and you'll notice that your derivative is above the x-axis, i.e. positive. The slopes become less and less steep as we tend towards 0, and you'll notice that your function's derivative, in this case in orange, is also tending towards 0. Once we hit 0 here, you'll notice that the function is now increasing, and you'll also notice its derivative is above the x-axis. Now make an observation here. You can see that the derivative, y equals 3x squared, is always above the x-axis. And because of that, that means the function is always increasing. And notice that your y equals x cubed function, as you read it from left to right, is always an increasing function. So the function in green, y equals x cubed, is always increasing, and its derivative is, that's why it's always above the x-axis here. And lastly, here we have our function in green is y equals 1 over x, and its derivative is -1x cubed. So notice here, as the function progresses here, 1 over x, the slopes are becoming less and less steep. It's a decreasing function, so our derivative is below the x-axis. And notice here that the slopes become less and less steep, and likewise your derivative is tending towards 0, neither of which will actually be at 0. So let's take a look at that again. As you graph your 1 over x function here, kind of focusing our attention on the right-hand side of the Cartesian plane here. So you can see here that as our function in green here is tending towards 0, the slopes are becoming less and less steep, closer and closer to 0, and our derivative, which is always going to be below the x-axis, and the reason for that is the function y over x is always decreasing, and therefore its derivative will also always be below the x-axis. And you can see that once more again here, right? Our function is continuously decreasing, 1 over x, and its derivative is always below the x-axis. So that concludes today's lesson on functions and its derivatives. Try to rewatch this, make these connections that I've been pointing out, and see if you can see them.